Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, today's session is on measure of variation or dispersion. In some book, it is measure of variation, or in some other, you may find measure of dispersion. This session is very much related to our previous session, which was at the measure of central tendency. And I'm sure you have learned a lot in measure of central tendency, the concept and idea behind. But here, inshallah, you learn how this session, particularly measure of variation, that is related to that one. We will learn some other statistical tools in this topic such as range, variance, standard deviations, quartile and interquartile range. The concept and the idea is clear. Why? Because we have discussed them in greater detail in class. But here inshallah you'll learn how to apply the statistical function in Excel inshallah, how to use them in Excel. So first, in the measure of central tendency, we have learned how to find out the central value in the population or sample data we have. For example, one of the statistical tools you have learned about in measure of central tendency, that was mean. And the function which is used to return this mean value, that is average function in Excel. Okay. So our claim is that the measure of central tendency, the tools we use such as mean, median, and mode, they are for specific purpose. But there are some other informations which are not captured by these central values. For examples, we have different salesperson here like Ali, Aslam, Ahmad, and each and every one generated different amount of sales in K amount. So Ali generated 3K amount of sales, Aslam generated 21K amount of sales, Ahmad generated 5K amount of sales. But by average, each and every individual salesperson generated 10.88K amount of sale. But this is only telling us what is the central value that is representing the whole population, or you can say the average sales of each salesperson in a month. But there is some other information, such as, for example, have this sales points, have Ali sales, for example, is closer to the mean value. So we see or we observe there are some sales value which are monthly sales value which are farther away from mean, and some of them they are closer. The 10 is closer, the 12 is closer, this 21 is somehow farther, 3 is farther. So in our analysis today, we are learning how each and every data set points is different from the central value. And for this purpose, we have measure of variation or dispersion. So dear students, the measure of central tendency is only representing the typical value of the population or data sets we have, but it does not capture how much variations or dispersions we have in our data sets. So today you are learning that how the data set is scattered out, how all these data set points are spread around the central value, or we can say how they are clustered around the central value or the mean value we have in our data sets, which is 10.88. For example, I'm copying this central value and paste it here, click on paste special and click on value and drag it down. So now we are comparing how each and every data set point is related to our central value, how closer or farther than central value is. So this is our average value. Very much simply take the graph of these two columns, go into insert, click on this 2D line. Here we have this one. This is more clear. Look in this data set, this is the central line we have, in all these different points around that is our actual point. So you can say how dispersed our data set is, or how closer these data set points to the average line is. So the more variation you observe here, such as here and here, and we have close or lesser variations we have here. So we can say here we have less variations, and this side we have more variations. So the closer these data set points to the average line or central line, as we say, there is less variations. And the farther these values from our central mean value is, then we say there are more variation. So our today's session is talking all about this variation, not about central tendency or central value, just variation, how these data is clustered around the data, how the data is spread out or scattered. So that is very much important in statistical analysis, dear students. Okay, for example, the first tool inshallah I learned is range. And the function we have in range is just to subtract the minimum value in our data set from the maximum value. If you observe here, we have the minimum is 3 and the maximum value is 21. So the difference between the minimum and the maximum, that is the range value. Okay, we have a straightforward function in Excel for different statistical tools, but we don't have it for range. So that's why we have a way out how to find out the range value. So click an equal sign and type max. We have a function of maximum value. This max is returning the maximum value. Just find out the maximum value and then we subtract the minimum value, right? These two functions together, they are used to find out the range value. So now we are telling Excel to subtract the minimum value from the maximum, and that is the definition of the range simply. Now the range value is 18. So what is the interpretation of 18? The higher this value is, the more variations you can observe in your data sets. The more fluctuations or volatility you can observe in your data set. The less or the smaller this value is, the less variation in your data set is. But keep in mind, dear students, most of the time in statistics or in research analysis, the range is not relied upon more. The reason behind, because this range is dependent or based on the minimum and maximum value. And it is quite possible, or you can say this is very much probable, that these two values are significantly different from the rest of the population value or the rest of the sample value or the rest of the data set points you have in your example. So once the range is relying only on the minimum and the maximum value and neglecting the effect of other values you have in your data set points, then that is why this range is not reliable. The range is telling us the difference between the minimum and the maximum value, and from here you can guess how spread your population data is or sample data is, how scattered that is around the central value. So that is why we have some other more reliable statistical tools such as variance and standard deviation. Okay, now we are talking about variance, dear students. The function we have for variance, this is the function. This is the manual functions you can use for variance. What is a variance? We have already discussed the concept and idea of variance in much detail in class, but straightforward, very much simply here, the variance is the average of the square deviations we have. So this is S square, which is the counterpart of the population parameter functions we have, which is sigma square. In case of the population, if this is the whole population data, then we have a sigma square. But if it is a sample data, we are using the S square, which is for the sample data. But in the population function or formula, we have capital N, but in the sample data, we have N minus 1 degree of freedom. It means you should subtract the 1 from the number of populations you have in your data sets. Now, very much simply, there is no need in Excel. I have given you the concept and idea behind this function I've used, inshallah, if you remember in class. But here we have a straightforward function in variance. Have to find out the function. Just for the sake of simplicity and demonstration and concept, I'm just doing it manually. If you do it manually, if you just try to find out the variance manually, so what is the way out for that? I'm just okay, and now I just did this. Look here, dear students. As I've told that the variance is the average of the square deviation, then first you have to find out the square deviation. What is square deviation here? Okay, x minus x bar, this is deviation. All these values represent our x values, and our x bar is our average value. We already have it. So what you should do is you should find x minus x bar. X minus x bar. This is our deviation. And if you find out the deviations, click on this value, and from each and every single point of the x observation, you should subtract the mean value. But I'm telling the Excel to stick into this reference. But if you do not stick into this reference and you drag it down, then this Excel is taking all these empty cells. Have to do that, just click here and press F4. In F4, we have just $sign before C, $sign and before 11. Now when you drag down all these values, you have variation. These are called deviations. Half each and every data set point is deviated from our central value. Now, once you have all these deviations, like x minus x bar is deviation, the second step is you have to square these deviations. So what is the function x minus x bar? Okay, x minus average value, and then you should square it. Okay, what's the purpose behind squaring? Why? Because we have some minimum, we have some negative value and positive value. If you straight away find out the average of these deviation, then that is giving you the misleading figure. Why? Because the negative and positive, they are offsetting each other. And to avoid such problem, we just square them just to have positive values. Simply, we have a function. What is a function for squaring? You can multiply each and every value by itself. One way is simply just to multiply each and every value by itself. The second value, we have a function of power. Just type power and click on number, and then what is the value the value, okay, the power. What is the power? The power here is 2. Why? Because we are telling Excel to raise each and every single value to power 2. Now we have the same result. Just drag it down. Now we got x minus x bar. In our functions, in the nominator, we have summation x minus x bar. We found x minus x bar. The next step is to find out the summation, to add them all up. And how to do that? Very much simply. When you find out the summation, just we have function, sum function. In the sum function, you can take the whole data in the range and you will have the summation. So we found out in the nominator the summation x minus x bar square. The next step is to divide this by the number of freedom, or you can say degree of freedom, which is n minus 1. In our situation, it is sample data once again, and for the sample you should use n minus 1. So the n number is 9, n minus 1 is 1, n minus 1 is 8. So it means you should divide this value by 8. Once you divide it by 8, then you can get variance. So this is so much time consuming and very much lengthy way. And this was just for the purpose of concept, but we have straight away very much fast and simple built-in functions in Excel for variance, and that is just equal sign and write variance. Variance.s. When you type variance.s, take all the original value, right? This original value and range and click enter. Now, look, the results we have, both of them are same. Okay, this variance function is returning the same result we have computed using this function or formula. So dear student, the concept here is variance. Once again, what is variance? Variance is only the average of sum of square deviation. And this variance is telling you how dispersed the data is, how much variance we have in the data. For example, these are the deviations, or you can take the average data from here. And just click on insert, and we have this 2D line, and here click on line with marker. Look, this fluctuation, the ups and downs, these are the variance. But these are the deviations or fluctuation. The variance function is just telling us that how much this variation or this fluctuation is. So the higher the variance value is, the higher this fluctuation or volatility is. The closer this, the smaller this value is, it means the lower the volatility is. So we have here some fluctuation, the variance is high. But keep in mind, this variance is computed in a way we have square all these different values. So we can say the variance is the average value of the square deviation. These deviations around the mean, we made them square, and then we sum them and we have found out the average of that, and that is called variance. And I'm sure, inshallah, you have learned the concept we have talked about in detail in class. Okay, the next point is standard deviation, dear student. In standard deviations, we are taking the square root of the variance amount. The same function, just we are taking the square root. For example, this is a function, right? This, I'm using this pen. This is a function. When you just take the square root, this is square root, then you can find out standard deviation simply. And that is the formula for square root. When you take the square root of the variance, that is giving you standard deviation. Got it? So here we have straight away very much simple function. The detail we have already talked about the concept of standard deviation, but here the function is just type SDT, standard deviation, STD, standard deviations, and we are using standard deviation for sample data. And just take all these values, the original values of monthly sales and the range. They will have a standard deviation here. So this is a standard deviation. What is the difference between variance and standard deviation? Variance is that is the average of square deviation, but here we have removed the square, the power value. We have removed and we have returned the value into its original form. Now you can say the volatility we have. For example, this is our data sets, and click on insert and click here on the 2D line and click here. This is the volatility we have, the ups and down we have. Look here, we have more volatility, here we have less volatility. But what is the standard volatility? The average deviations around the central value you can observe here. So you can, the average volatility here is 5.86. By average, each and every point deviated from the central value by the amount of 5.86. So this is the standardized value. The variance is, some have not standardized because it has captured the square deviation. Somehow you can guess from the amount of variance how much the total variance is, but if you just return it back into the standard value, which was the original value without the square, that is now 5.86, and that was simple, just we have taken the square root of the variance. Okay, dear students, the standard deviation is 5.86. It means by average our deviations ups and down around the central value, that is 5.86. I hope the concept is clear. Okay, uh, this was the standard deviation for a very much small data sets we have in, that is monthly sale. So you can say, have to interpret this 5.86. It means each and every sale is deviated by the amount of 5.86k amount. You can say, you can guess that we have different salesperson and the monthly sale is 10.88. So this 10.88 is not confirmed and sure, and there is probability that this sale can be deviated by the amount of 5.86. It means there are chances that the sale met around to be 15.86 if you add these two values, or this average value may turn out to be less than 5.8 by the amount of 5.86. So the standard deviation mean that this average value can be deviated into extreme, either higher by 5.86 amount or lower by 5.86 amount. Okay, the next we have here student, that is quartile. Quartile in Q2 and Q3. But before quartile, I just try to give you some real scenario of standard deviation. Sometime in stock market, most of the investors, they just try to find out risk, the fluctuation in the stock price, to know how much the standard deviation in the stock price is. So I'm just practically telling you how to find out the standard deviation in stock price and what is the interpretation of that. It's very much important. Look how I'm just doing that. Okay, for historical stock price, just come to Google. And Google, we have a website by the name of Stoop. Right, click on Stoop, and this website you can find out. You can find out. You can find out many stock price data. Okay, this is the problem. Okay, when you open the Stock website, in this website you can find many more stock prices, especially historical stock prices. Okay, what company you are interested in to know about the standard deviations or risk of that company. For example, I just try to find out for Google. When you just enter Google, the name of the Google company or the alphabetic company or the code is appearing. Just click on that, and then you'll have all the data. But we are interested in historical data. Click on historical data, right? And then, okay, for example, you just try to find out the fluctuation or volatility. You can say the risk in the stock price of the Google company. Okay, you can choose the data. If you want to take the data for last 4 5 years or 10 years, the more data sets you are taking, the more reliable and accurate your standard deviation may possibly be. In the less value you are taking from the data set, you can say the less reliable your standard deviation is. So not too much data, you can take at least 5 years data. For example, I'm just taking data from 2000. Okay, here I'm just 2020. I think 2020 should be the beginning, and December, and here I'm choosing 31st, and up to December 31st 2025. Okay, and show. Now this is the monthly data starting from 2020 December 31st and to December 31st 2025. But you can take weekly and daily data. If you take daily data, so you'll have huge data sets. Okay, now I'm just clicking on download data in CSV file. Okay, once the data is downloaded, okay, click here in the data. Okay, this is the data set. Okay, this is the data and this is the opening price of the stock of the Google company. This is the high price, this is the low price, this is the closing price. We are interested in closing price because most of the time the trade is happening on the closing price. Or if you are determining the future stock price, so the closing price of the stock price is considered most of the time. Okay, now this is, I'm just increase the column here, and this is the stock price. You can see the stock price, Google stock price. Dear students, in this analysis, we have stock prices. In from the stock price we just try to find out the fluctuation or standard deviation, have these data set points fluctuate over time. And inshallah I'll explain how to interpret the answer of standard deviations using stock prices here. Okay, first you should source the data, and how to source the data, bring the recent data into the beginning, or you can bring the lower or the old data into the beginning, whatever options you are using. But here in our analysis, I'm interested in sorting the data. Okay, click on this and then go into sort and click on custom sort and take a date here, right? And then I'm sorting the data not from, yes, from oldest to newest is okay. This means the recent data, the recent data is coming to the first if you choose newest to oldest. And if you're choosing oldest to newest, then the older data is coming to the first, to the top, and the newest data is just going to the end. But now just we bring the newest, the recent, latest data into the top. Okay, now look here. You can say the very much recent price, that is 1.51, and the price a month before that was 154, and then 170. Now what we are really interested is that is the return in these stock prices. Why? Because these are just simply the stock prices. You have to find out return, and the return in our analysis, that is our x, that is what the x observation in our function, if you remember. Okay, have to find out the return. In finding out the return, you should take the recent price, which is this one, right? Take it in bracket, the recent price. And from the recent price, you should subtract the previous month price, and that is 154.67. And then you should divide it by the previous price. Once again, the recent price minus the previous price divided by the previous price. Okay, click. This is the return. It means in this month there is a loss. Why? Because the previous price was 154 and now the price is 151, so you can say here is a negative value. We have a negative return here. Okay, drag it down here. So we have returns. So you can say continuously we have loss here, we have a positive value, positive here, we have loss. These are returns of the stocks each and every month. Now the point here is just we try to find out what is the volatility or standard deviation. Okay, what is the variations here? Simply, if you choose or when you select this data set here, that this is the data sets of the stock prices we have. The last one is here is this is missing. Why? Because we don't have any value here. That's why you should remove it. And look, click here in this function. There is no value. That's why the value is not returned here. Okay. Okay. Simply just select this data set, right? Or if you select it with the label here, okay, and click on insert and check the volatility or fluctuation. Look into the volatility. This is the volatility in the return values of this the Google stock price. The more volatility you observe, you can see the more variations or the more standard deviation is there, right? The more risk is there. The standard deviation is just letting you know what is the fluctuation, the standard fluctuation. But here we have more variations. It means here we have some risk. The stock price over the period is not much stable. There are some values which are more deviated, some values which are closer, but still there is variation. Now we just try to find out what is the average or standard variations we have. So we have simply the function of standard deviation. And what is the standard deviation function here? Okay, we have standard deviation. But keep in mind, dear students, as this is the sample, not the whole entire population, then we are using the sample function for standard deviations. Equal sign and standard deviation, take the standard deviation that is, and take the whole data of the return in the range. And then you'll have the standard deviation is 0.079. What does this mean? This is the average fluctuation. This is the standard fluctuation around the mean. Okay, for example, you have to convert this into percentage. Okay, 7.97. What does this standard deviation mean? For example, if we take the average value, what is the average value? The average value of this data set points and average return, you can say that is, sorry, just type average here, and the function should be here, average, and take the whole data. We have made mistake here. Now it is average, and here use the average function. Okay, the average value, okay, in statistic we use the word mean. The mean value is 0.0311, right? Okay, if you convert it into the percentage, you can say the average expected return in the stock price, that is 1.37. But keep in mind, this return 1.37, this return can be fluctuated by amount of 7.94, right? Okay, let me remove the percentages big from here. Yes, format cell, click on general value. Okay, this is the mean value and this is the standard deviation. It means this expected value is not sure. There is probable fluctuation. You can say this value can be fluctuated. How much? By the amount of 0.79 up and by the amount of 0.79 down. So in stock analysis, most of investors, they are using standard deviation, and standard deviation can help them find out a very much good opportunity for their return. So if you know in investment analysis, we just try to figure out which investment opportunity is having more return and less risk. So some of them, they are concerned about the risk. One of the measurement for risk is standard deviation, because the standard deviation is telling them how fluctuated the data set or the stock prices are. Okay, one point here, just let me tell you. For example, this is your expected value, mean value. What if this expected value goes up by this amount, or if it goes down by this amount, right? Okay, here we have function. For example, once we make it high and once we make it low. Okay, if this amount increases, this amount, right, increases by this standard deviation amount, then you should multiply this with 1 plus this amount, right? Okay, if it is increased, then higher value is 0.01. That is 0.014. And if it is decreased, the low amount is just put equal sign and click on the mean value, right? And multiply this, start the bracket, and then 1 minus, click on this value, right? Okay, very much simply, what I have done here I have increased the mean value by the standard deviation amount. It means this mean value can be increased into this value, which is 0.014, or this mean value can be decreased into 0.041. There is a fluctuation possible, and the fluctuation possible by amount of standard deviation. If you increase this value high by the amount of standard deviation, so it may turn out to be this value, and if you decrease this, then it may turn out to be this value. So we can say this mean has risk. And what is the risk? It may go up by this amount or may go down. It may go up to this amount and may go down to this amount. So this fluctuation is by the amount of standard deviation, that is 0.07. This is the magnitude, the level which probably your mean value increases or decreases. Okay, I'm sure you have learned the idea of standard deviation. Also, you have learned how to practically find out standard deviations using historical stock prices. The next point we have is quartile and interquartile range, dear students. Okay, first, what is quartile? One, we have Q1, Q2, and Q3. For example, in the analysis of quartile, it is very much important to have a data in order, right? In quartile, we try to find out what is the 25th percent value and what is the 50th percent value and what is 75th percent value. Just the quartile is distributing your data sets in four equal quartile. The first quartile is the 25th percent value. Now, for that purpose, you have to arrange your data sets. And how to arrange it? First, just remove the mean value, select your data sets, right? Go into sort and click on customer sort, and now sort this data using monthly sales amount, okay? And now make it from smallest to largest. Look here, just correct this back 1 2 3, and now the data is organized. Now, what is the Q1 or first quartile? Here we just try to find out what is the first 25th percent value. In the quartile, first the data should be divided into two equal parts. So we have 9 observations. The middle value here is 10. This middle value 10 is our median. In our analysis, is median. You can call it 50% quartile. This is the 50% level of data. Okay, the 25th percent quartile, for the first Q1 quartile, first you need to find out what is the central value, which is the median value. Then after that, you should look here. In this value, what is the central value? If we have odd value, then the central value is just very much easy to find out. But we have even here, we have 4 values here, and we have 4 values here. So the quartile here is just you have to take the middle value here and find out its average. You can see the middle value here is the 5 and 7 should be added together, and the mid value is quartile. So this is the first quartile comes here, and this is the second quartile, which is the 50th percentile. The first quartile, we call it the 25th percentile. In the second quartile, which is 10, we call it median. Also, we call it 50th percentile. And the third quartile then is coming here. Now you should, in this order, just look what are the middle value. We have even value here. Then the middle value is the average of 13 and 18. When you take the average of 13, that is the 75th percentile. Okay, how to find out? Very much easily. There is no need to do it manually. If you have a very much huge data set, then we have a function here. For quartile, you should write quartile. In the quartile, use the first function of quartile excluded function, but because the upper and minimum value should be excluded. So click on this quartile and then take this value. Look, what is, okay, yeah, in the quartile, when you just take the value, then you should tell the Excel that return the first quartile. Okay, the first quartile is the 25th percent of the data sets you have. Okay, this is the first quartile. Look, this is the median value, and the first quartile is coming here. What is the mid of the first quartile? The mid is just to take the average of 5 and 7, and the average is what? 6. And what is the second quartile? Just you should type the quartile here and take all the data here and tell the Excel that to return the second quartile. And the second quartile value, as I've told you, that is the median value, that is the middle value. You can also call it 50th percentile. In the third quartile, the function we have for the third quartile is simply just type quartile and use this function and take all the data here. And the third, once again, just tell the Excel to return the third quartile here, comma 3. So the third quartile is 15.5. And this is 15.5 percentile. This is the 75th percentile. Okay, what is the interpretation of this quartile value? The quartile 6 mean the 25th percent of the data lies below or beneath 6, right? And you can say 50% data is below 10 and 75% data is below 15.5. These are the ranges, okay? The median is 10, means most of the data that is below 10. And then 75% data that is below 15.5. And you can say 25% data that is below 6. Okay, what is the interquartile range? The interquartile range, that is the difference between Q3 and Q1. Okay, So how to find out the interquartile range? Just simply click on Q3 and then subtract the Q1 value from, right? Then you can say the interquartile range, which is the central value, that is the difference between Q3 and Q1. This is just telling you that how dispersed your data is, how clustered your data around the mean is also. The interquartile range is just taking the middle value. The middle range is just taken. The higher the middle range is, it means more data is closer to mean. And the lower this middle range is, means less data is closer to the mean. Okay, these were the quartile analysis. Q1, and once again, this is the 25th percentile, means 25% of the data is below 6, 50% below 10, and 75% is below 15.5. And this is the middle value, which is called interquartile range. Okay, dear students, for quartile analysis, or just to know the graph for this quartile, we have a specific graph by the name of Buck's plot. So click here and click on insert. Within the insert, we have a special graph, and that is by the name of Buck's, this one. Click here and we have Buck's and Whisker. Click on this. Okay, this is the graph, and this graph is called Buck's plot. And okay, don't worry, I'm just explaining it. This is the Buck's plot, and the data we have, this is for monthly sales. Okay, dear students, in this Buck's plot, you can analyze it. Just click on this, right click and format on the, right click and add on the data label, then click on data label. Now the data label is here. You can just change the format. I'm just liking this format, right? This format is okay. Once again, then click on the, in this area, right click, and once again right click and add data label, right, and add data label. Now the data label we have, let me make it red color. Okay, dear students, this graph is called Buck's plot. Now in this graph, this value, which is the middle line, this is called median. So the median in our data set, that is 10, right? And this value, which is 15.5, this is our 75th percentile, and this 6 is, this is our 25th percentile. So you can say the 25th percent data is below 6, and up to this point, this is 75th percent data, and this, which is in between, this is the difference between the Q3 and Q2. The difference is here, this, the blue area, you can see this value. This is the interquartile range, and you can see the whole data range here. This is 9.5, this value, and this is the average value, the central value in our data sets. You remember that is 10.88, the central value, the average value. Once again, up to this point, up to this line, we have the 75th percent data, 15.5, and up to 6 from the beginning, starting from the beginning up to 6, this is our 25th percent data. But in between this 6 and 15.5, this is interquartile range. This is a line, interquartile line. And I have told you, the more if this plot area that is bigger, it means the data is more central around the mean. So the more data here is in, it means that the data is less varied, right, and cluster around the central data. Okay, these two lines, which this line and this, these are called whisker. This is whisker. So the whiskers, they are showing the maximum value, which is 21 in our data set is the maximum value, and 8 is the minimum value. And above 21 and 8, if you observe any value about these whisker, the maximum and minimums, we call it outliers. If you remember, we have work on in strata analysis. So once